mesh analysis. Under this topic, we will see how we can simplify the circuit. Mesh analysis is used for circuit simplification, and you can determine the mesh currents. You can also determine the branch currents in the circuit. So to understand this, let me consider a simple circuit. Say I have this circuit wherein I consider the voltage source E1. I have resistance R1, resistance R2, resistance R3, and another voltage source E2. Let me name these nodes so that I can clearly identify the meshes. This is A, C, D, E, F. So when you look at this particular circuit, what do we see? We have basically two meshes, right? Two individual meshes. So you have the first mesh, let me name this as M1, which is A, B, C, D, A, and you have mesh 2, which is B, E, F, C, B. For these two meshes, in order to determine the mesh currents, what we are going to do is we are going to draw the mesh currents in clockwise direction, that is in this form. So I will name the first mesh current as I1 and the second mesh current as I2. Once we draw the mesh currents, we will apply KVL to these individual meshes. So say I want to apply KVL to the mesh 1, I can write this as, by considering the right polarity, this as E1 minus I1 into R1, because this is the mesh current, right? I'm talking about the first mesh. So the mesh current is I1, so it is minus of I1 into R1 minus of, now if you observe, we have two currents here between across this resistance R2. You have the current I1 here and then you have the current I2 here. When I write the KVL equation for the first mesh, that this becomes your dominant mesh. So the equation will be, across the resistance R2, it will be I1, this is the dominant mesh, minus I2 into R2 is equal to 0. So this is your first equation. Next, say you are applying KVL to the second mesh, right? So again I have considered the current in the clockwise direction. So this is plus, this is minus. So when I write the equation, I need to start from here. So this is minus of, what is the current in the second mesh? It is the current I2. So minus I2 into R3 minus E3. So when I am talking about this particular mesh, this will be positive, this will be negative because of the direction of the current, which is clockwise. So this will be minus of, now again this resistance R2 is being shared between the two meshes and the dominant current here is the current I2. So when I write the equation, this will be I2 minus I1 into R2 is equal to 0. So this is your equation 2. Now you have two equations with two unknowns, and the two unknowns are the current I1 and the current I2. So you need to solve these two linear equations and determine the value of the currents I1 and the currents I2. And these currents I1 and I2 that you have are nothing but the mesh currents. Okay. Now say you want to determine individual branch current. So if it is across a resistance R1, the branch current is the current I1 itself. If it is across the resistance R3, the branch current will be the current I2 itself. But if it is across the resistance R2, the branch current will be depending on which you consider as the dominant mesh. If you consider the dominant mesh as mesh 1, that is this mesh, then the branch current across this resistance, that is R2, will be I1 minus I2. Whereas if you consider mesh 2 as the dominant mesh, the branch current will be equal to I2 minus I1. Now in mesh analysis, we have three different cases, okay, that we need to consider when we are solving the numericals. So let us look at the first case. This is a case wherein you do not have any current source. So as a procedure that I have explained you just now, the first step would be to determine the number of meshes that are there. So when you observe here in this particular circuit, you have two meshes. This is mesh 1, this is mesh 2. You need to draw the mesh currents in the clockwise direction and name them. So I will call this as current I1 and I will call this as current I2. Now what we need to do, you need to just apply KVL to these individual meshes. So I can write the equation as, for the mesh 1, on applying KVL, I can write this as 10 minus 5 times I1 minus 5 I1 minus I2 equal to 0. So this is my first equation. When I consider mesh 2 on applying KVL, I get this as, this is again plus minus, this is plus minus, so it is minus 10 times I2 minus, the dominant mesh is 2, so it is I2 minus I1 into 5 equal to 0. So now there are many ways in which you can solve these two linear equations. One method is the Cramer's rule, wherein you compute the determinant by writing these two linear equation coefficients. Okay, you can also do it directly using your calculator. That would be simpler for you. I do not want to complicate things here. You can simply solve this using your calculator by going to the calculator mode, equation mode option, and specifying the number of unknowns that are to be entered and then solving it. So this is a case wherein you do not have any current source. So it is just simple that you have to just apply KVL to the circuit and obtain the linear equations. Now let me explain the second case. So in the second case, if you observe, you have a current source which is present exclusively to one particular mesh. So like the way we follow the procedure, we consider this as mesh 1 and we consider this as mesh 2. I will write or draw the mesh currents. This would be I1 and this would be I2. So for the mesh 1, when I apply KVL, you have this as 90 minus I1 into 9 ohms minus I1 minus I2 into 6 equal to 0. So this is my first equation, right? When you look at the second mesh, you have a current source exclusively for that mesh. That means it is not a current source which is being shared between the mesh, it is exclusively for the mesh 2. So if you look here, this current I2 is already equivalent to the value that is specified in the current source. So from mesh 2, what we obtain is that the current I2 will be equal to minus 5 amps. Okay. The reason why the polarity is negative is because the direction of the mesh current that we have considered and the direction of the current source that is being specified are opposite to each other. So if the direction of the mesh current and the current source were in sync, were in the same direction, I could have mentioned this as I2 to be equal to plus 5. Since they are opposite to each other, this becomes equal to minus 5 amps. So once you know the value of one of the currents, it is very simple. You just need to substitute here and determine what is the other mesh current, that is I1 in this particular. So let's move to the case 3. This is one of the cases where you have many problems that will be appearing to you, especially in the mesh analysis. So this is a case where you have a current source which is common to the meshes. Okay, so in order to make things simpler, I have considered just two meshes. So this is my mesh 1, this is my mesh 2. Okay, so I need to draw the mesh currents, right, as the procedure is. So this would be the mesh current I1 and this is the mesh current I2. Now whenever you have a current source between the two meshes or being shared between the two meshes, you cannot directly apply the KVL. Okay, so what we consider is, we consider a super mesh. Super mesh can be formed only if you have a current source between two meshes. So let me draw the super mesh. The super mesh will always be drawn around the current source. Okay, it will be drawn around the current source when the current source is shared between the two meshes. So when you have a super mesh, the first thing that you do is you will always draw this super mesh around the current source. Okay, now you need to write the constraint equation. Okay, constraint equation is an equation which will give you a relationship between the mesh currents, that is I1 and I2, and this current source. Okay, it will give you a relationship between the mesh currents, okay, and this current source. So if you observe, how is this current source direction? It is pointing upwards. It is in sync with the second mesh current, right? That is the current I2. So I can write the constraint equation as IS, the current source equation, current source value, which is represented as IS, to be equal to, which is the dominant mesh in this case, because it is in sync with the mesh current I2. So I can write this as I2 minus I1. So this is a constraint equation which gives you the relationship between the mesh currents and the current source that is present. So if you have written the constraint equation, this would be your one linear equation. Fine. For obtaining the second linear equation, you need to apply KVL to the super mesh. So when you apply KVL to the super mesh, how do you get the equation as, this will be plus, this will be minus, plus, minus, right? So you can write this as, the source voltage is Vs minus the current corresponding to the resistance R1 is what? It is the current I1 in the first mesh. So this will be minus I1 into R1 minus, what is the current that is flowing across the resistance R2? It is the second mesh current, that is I2. So you have minus of I2 into R2 is equal to 0. So you have here also, you will have two linear equations with two unknowns, which are I1 and I2. You need to solve them to obtain the mesh currents I1 and I2. Solve a numerical. Find the mesh currents for the network shown using mesh analysis. So you need to use all the three cases. If you have clearly understood all of the three cases, you need to apply that here. You need to identify the number of meshes. So how many meshes do you see in total? 3 meshes, right? So you have, this is mesh 1, this is mesh 2, this is mesh 3. So the number of meshes is 3. So you will have in total 3 mesh currents. So let us mark those mesh currents, and we mark the mesh currents in the clockwise direction. So we have looked into 3 cases of solving the mesh analysis, and you can see in one of the cases I specified that you have a current source exclusively to one of the meshes. So here in this case it corresponds to the mesh 1. You have a current source exclusively to the mesh 1. So when you consider the mesh 1, for the mesh 1 you directly can determine what is the value of current I1. So I1 is equal to 10 amps. Now next, what you can do, what about the other meshes? You need to apply KVL to them. So apply KVL to mesh 2. So when I apply KVL to mesh 2, I get this as, this is plus, this is minus, this is plus, this is minus, right? So this becomes minus 2. Again, I am considering the mesh 2, which is the dominant current here. The current I2 is the dominant current. So when I write the equation for a resistance which is being shared between the two meshes, make sure that you write the equation in terms of the dominant current. So it is minus 2 times I2 minus I3 minus 10 minus 3 times, again the dominant current is I2, so this becomes I2 minus I1 equal to 0. So let us simplify this so that we get a clear and a neat equation. So you can write this as, what is the value of current I1? I1 is 10 amps, right? So substitute this and simplify this equation, and you get this as minus 2I2 plus 2 times I3 minus 10 minus 3I2 plus 3 into 10 equal to 0. So I can write this equation as minus 5 times I2, 2 times I3. This is plus 20. Plus 20, when you bring it to the right hand side, becomes minus 20. So this would be your first equation. Similarly, apply KVL to the third mesh. So when you apply KVL to the mesh 3, you get this as, again this mesh current is in the clockwise direction, so this becomes plus minus, this becomes plus minus here. So this is minus 3 times I3 plus 10 minus 2 times, which is the dominant current? It is the current I3. So this can be written as I3 minus I2 equal to 0. So I need to rearrange this equation so that I can obtain a neat linear equation. So I get this as plus 2 times I2 minus 3 minus 2 is minus 5 I3 equal to, this is plus 10 here, when I bring it to the right hand side it becomes minus 10. So use your calculators, try to solve these two linear equations and see what you get. You can even use the Kramer's rule if you know, else you can just directly solve using your calculators. So on solving these two linear equations, you will get the value of current I2 as 5.71 and the value of current I3 will be 4.287, and I1 already we have computed in the mesh 1, right? So I1 value is 10 amps. So we have determined all the three mesh currents, that is 10 amps corresponding to I1, I2, and then we have determined I3. So they can also ask you to determine the branch currents also, and I told you how to determine the individual branch currents if it is being shared between the two meshes. Okay, need to identify which is the dominant mesh and accordingly write the equation. So here is a second example. We are supposed to find out what is the current that flows through this 28 ohm resistance using mesh analysis. Now if you see here, we need to apply all the three cases that we have looked, because we have a current source which is exclusively for one particular mesh. Then if you see this particular circuit, you also have a dependent current source. So we have seen if there is a current source between two meshes, we need to use the concept of supermesh. So individually, first let us identify the total number of meshes that are present. So let me mark that this is mesh 1, this is mesh 2, and this is mesh 3. So let me draw the mesh currents in the clockwise direction. So this, I will mark this as I1, this current as I2, and this current as I3. So from the 12 ohms current source that is available to us, I can write from mesh 1 I get the current I1 to be equal to 12 amps. It is plus 12 amps because the current I1 is in sync with the current source. So the direction of current source and the mesh current is the same. So I can directly write this as plus 12 amps. Now, when you look at the mesh 2 and the mesh 3, you have a current source being shared between them. Whether it is a dependent or an independent current source, whenever you have a current source shared between the two meshes, you cannot apply KVL directly. So you need to mark the boundary of the super mesh. So let me mark the boundary of the super mesh, and the super mesh has to be considered around the current source. So this is how I will mark. So this will be the super mesh. Now let me write the equation for the constraint. So constraint equation, as I told you earlier, it is a relationship between the mesh current and this particular current source. So you will have constraint equation as 2I to be equal to, look at the direction of this current source. It is pointing towards the right hand side, which is in sync with the mesh current I3. So you have to consider I3 to be the dominant mesh. So you can write the constraint equation as 2I to be equal to I3 minus I2. So this becomes your first linear equation. Then you need to apply KVL to this particular super mesh. So when applying KVL to the super mesh, what do you get? I need to specify the polarity. So let me mark this. This is plus minus, this is plus minus, this is plus, this is minus. So I can write this as minus 4 times the current that is flowing in the mesh 2 is I2. So minus 4 I2 minus 8. The current flowing here is I3 minus, this is 28 ohm resistance, and this is being shared between the two meshes, right? So the dominant mesh here is I3, so this is minus 28 into I3 minus I1 equal to 0. So this is your second equation. Now we know the value of the current I1, so substitute this and see what you can reduce this equation to. So I can write this as, on substitution, minus 4 I2 minus 8 I3 minus 28 I3 plus 28 into the value of I1 is 12 equal to 0. So combine these terms, bring this constant term to the right hand side, and you have minus 4 I2 minus 36 I3 equal to minus 336. So this is your second linear equation, and the first linear equation is obtained by writing the constraint equation, right? Now here I is a value that is not being specified, and they have marked in the circuit where the I lies, right? So this value I is specified across the 28 ohm resistance. So if you want to compute the value of current I, if you observe, if I am looking at the mesh 1, the direction of this mesh current I1 and the direction of the current I is in sync. So if you want to compute the value of this current I, it would be more convenient if you consider I1 to be the dominant current. So you can write the equation for current I as I to be equal to I1 minus I3, right? So therefore, how can I reduce the equation 1? I can write this as 2 times I1 minus I3 equals I3 minus I2. I know the value of I1, right? I1 value is 12 amps. So substitute that and see what you get. So this equation can be reduced to, bring the terms which are common to one side. So this is going to be plus I2. This is minus 2 times I3, and this is again going to be minus. So this will be minus 3 times I3 equal to 2 into 12, that is plus 24. When I bring it to the right hand side, this is going to be minus 24. So you have the two equations after modifications. Let me name them. This is equation 3 and this will be your equation 4. So solve the equations 3 and 4 and see what you get. Solving equation 3 and 4. So use your calculators. You have two unknowns, I2 and I3. So solving equation 3 and 4, you get I2 to be equal to 3 amps and I3 is equal to 9 amps. The question is asked to compute the value of this current I, right, which is flowing through the 28 ohm resistance. You know I is specified here and you have computed the value. That is I is equal to I1 minus I3, right? The current that is flowing between these two meshes. So use that. So the current through 28 ohm resistance is I to be equal to I1 minus I3, and 12 minus 9 gives me a value of 3 amps.